So in this video, we have dependent current source, right? So you can see this diamond shaped signal symbol, that is I have 5ix. So if I want to find the RTH value, okay, so what you will do, so I have to remove this source, right? If I want to remove the source means you have to open circuit this one. If I open circuit this one also, um, uh, since this Ix is based on this source only, you can't get the value of Ix. Okay, so you see, let me take this one as V1, and I can write this is I1. Okay, so what are the incoming current? The incoming current is 5ix, incoming current to this node, that is equal to I1 plus ix, right? These two are outgoing current. So I1 I can write it as V1 by 4, and this I can write it as Vx, I can write it as Ix I can write it as V1 by 20. Okay, what is V1? V1 is equal to 20ix, right? V1 is equal to, these two resistors are in series, so this 20ix. So this I can write it as 20ix by 4 plus 20ix by 20. This is equal to 5ix plus ix. This is equal to 6ix. So I can write this 5ix is equal to 6ix. So this can be true whenever I can write 6ix minus 5ix is equal to 0. Therefore, ix minus is equal to 0. So that is true whenever the ix value is 0. Okay. So if ix value is 0 means I can't able to find the if ix is 0 means obviously V1 is also 0. If V1 is 0 means this is also 0. Okay. So in order to avoid this case, and you can't able to find the RTH and BTH and all, right? Because we know that okay, so we know that this RTH is equal to VTH divided by ISC, right? So in order to avoid this case, what I'm going to do is I'm going to connect an extra current source, that is 1 amps at the output of this this is 5ix, and so I'm going to connect an extra current source at this terminal. Okay, so from this I can write okay, I can write so this is now this is ix, right? And this is also ix. So V1 by 4 plus plus ix is equal to 5ix, right? So this I can write it as V1 by 4 is equal to 4ix. So V1 is equal to 16ix. Okay. Sorry. So I can write V1, this now it becomes VB, right? So V1 minus VB divided by 15. Okay, 15 plus V1 by 4, that is equal to 5ix. So this is my first equation, and what is VB? VB is equal to 5ix, right? And so you substitute here V1 minus 5ix otherwise, so I'm going to convert everything into VB. Okay, so I can write V1 minus V1 by 15 plus V1 by 4 minus VB by 15 and minus VB, that is equal to 0. So this is 19 V1 by 60 minus 16 VB by 15, that is equal to 0. Okay. So this is for the this node. Okay. So for this node, I can write VB minus. So now the current direction should be in the opposite direction. So you see, I can write VB minus V1 by 15 plus VB by 5, that is equal to 1. Okay, so I can write VB by 15 plus VB by 5 minus V1 by 15, that is equal to 1. So this is nothing but 20 VB by 5 into 15. Okay, minus V1 by 15 is equal to 1. So I can write V1 by 15 plus 4 by 15. VB is equal to 1. So this is your second equation and this is your first equation. So from this I can form the matrix, right? So the matrix value is 19 by 16 and minus 16 by 15, and this is minus 1 by 15, 4 by 15, that is equal to V1 VB, that is equal to, this is 1 and this is 0. Okay, so you can find the value of del now, and you can find the value of I need to find the value of VB, right? So I need to find the value of VB. So the VB is something but VTH5, right? So in order to find the VB, I need to find the value of del 2. So del 2 is nothing but 19 by 60 minus 16 by 15 and minus 1 by 15, 0 and 1. Okay, so what is del 2? Del 2 is 19 by 60 and you know the value of del. So from this one I can find the value of VB, del 2 by del. So that is nothing but 23.75. Okay. So the voltage across this one is VB is nothing but 23.75, 23.75, and I have taken this ISC as 1 amps, right? So answer is 23.75. Okay. So the Norton's equivalent resistance of the circuit is 23.75. So you know how to find the value of del, right? 19 into 60, 4 by 50 minus 16 by 15 into 1 by 50. Okay. If you solve, you will get the value of del. So if I divide, you will get the answer as this.